the hidden truth of Uranus, an ice giant that's not so cold. Uranus, the ice giant and one of the most peculiar worlds in our solar system, has always been a challenge for science. It spins on its side, with one pole experiencing a 42-year summer and rotates in the opposite direction of almost all its neighbors. But for decades, what truly baffled astronomers was its internal temperature. In 1986, the Voyager 2 probe's flyby suggested an unusual finding. Uranus was surprisingly cold inside, while its giant companions Jupiter, Saturn, and Neptune release much more heat than they receive from the Sun. A remnant of their violent formation 4.5 billion years ago, Uranus appeared to emit almost nothing, barely the heat it absorbed from our star. This thermal blackout defied the fundamental theories of planetary evolution. To explain it, scientists considered extreme hypotheses, such as the planet being much older and having cooled off completely, or even that the gigantic collision that knocked it onto its side might have blasted out all of its internal heat. As planetary scientist Amy Simon noted, all these projections hinged on that one single, irrefutable data point from Voyager 2. It was a true cosmic cold case. However, a team of scientists from NASA and the University of Oxford decided to reopen the investigation. Armed with advanced computer models and motivated to unravel this enigma, they set out to reevaluate the planet's thermal profile using decades of archived data. The team, led by Patrick Irwin, ran numerous simulations focusing on a key concept: Uranus's total energy budget. The goal was to compare the energy it receives from the Sun versus the energy it releases back into space, both reflected and in the form of heat. To do this, they had to refine atmospheric models that integrated every known detail of the planet, from hazes to clouds, obtained by cutting-edge instruments like the Hubble Space Telescope. And that is how the discovery arrived. The new research, published in the monthly notices of the Royal Astronomical Society, confirmed a truth that had been hidden for nearly 40 years. Uranus does generate its own internal heat. The crucial finding was that Uranus releases approximately 15% more energy than it absorbs from the Sun. It is residual heat, a remnant of its formation, and a figure supported by an independent study. While it is still far less heat than its neighbor Neptune, which emits more than twice what it receives. This discovery corrects the solitary and confusing data point from Voyager 2. This scientific breakthrough not only solves one of the most stubborn mysteries in our solar system, but is also of vital importance for the future of astronomy. By unraveling Uranus's thermal budget, scientists can better map the formation timeline of the giant planets, and crucially, given that the vast majority of exoplanets discovered outside our solar system are similar in size to Uranus. Understanding this ice giant allows us to better comprehend and characterize the thousands of distant worlds waiting to be explored. Uranus is no longer a simple cold outlier, but a key to unlocking the history of planet formation across the galaxy. Money